Okay, so we are starting now to talk about graphs that we can build from the tables that we put together. So we've gathered data, we're starting to take that raw data and we're starting to group that data together into tables. So we talked about frequency tables, we talked about relative frequency when you take each frequency and divide it by the total and get a percent. We've then talked about cumulative frequency when you start to add up all of your frequencies and they all end up totaling to the exact total that you have of the people or the points of data that you studied. And then we talked about relative cumulative frequency, which is when you take the cumulative frequency and divide it by the total, and that builds up to 100%. So now we're going to take these tables and turn them into visual representations. The main one that we talk about is histograms. We see it a lot. So histograms. First of all, we've got a bunch of table right here that deals with unemployment rates of 110 countries for 2017 as reported by the International Monetary Fund. We talked about today for some of you or the last class, we talked about what is descriptive versus inferential statistics. And this, because we're talking about something that happened in 2017, is descriptive statistics. So this is the unemployment rate. We need to create it into different categories or different ranges. We're going to take those ranges and then count up our frequency. So our ranges right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different slots. If we were trying to figure out what each range was, we would take from the smallest rate, which it seems to be about like 0, all the way to the largest rate is 27. So I'm going to do 30 divided by 10, which gives us 3. So we're going to jump in our range by 3. So we're going to do 0, 2, 3, and then 3 to 6, and so on. Okay, so here's our ranges. Now we need to go through and we need to count how many of these numbers are in these ranges. So we're going to go ahead and go through and count them. Pause the video right now and go ahead and count them. I'm going to come back and tell you the numbers that I found. Okay, so here are the numbers that I found of this data right here. And this is the frequency. Between 0 and 3, I found 9 pieces of data. The hard part here is that, nope, I take back what I was about to say. So the nice part here is that we've got it all organized. So you can go through and count. Up to this point, we've got 9 pieces of data. Those 9 pieces of data fit within that range. So making a frequency chart should be at this point pretty straightforward and pretty easy for us. So if we flip the page, we are then asked to construct a histogram using the data in the table by using your graphing display calculator. Sketch your histogram in the space below. We are actually not going to use our calculator for this guy because you have 110 different points of data, which means you would have to input all 110 of those data points into your calculator, and that's a lot. I'm going to do it with one of your later tables and show you how to use your graphing calculator to make a histogram. We're just not going to do it with this guy, but we are going to make a histogram. So a histogram is a visual representation of your frequency diagram. What we want is we want to build a graph, like X and Y axis type of thing. Where your X-axis is going to be the unemployment rate. And this is going to be representing your ranges. Okay, so I'm going to go by tick marks, and each tick mark is going to represent 3. I'm going to be precise on this guy. That was perfect. That's amazing. You just witnessed greatness. Okay, so we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So that represents each of our ranges from our table on the previous page. On the y-axis of a histogram is where we put our frequency. So this means how many times in the range between 0 and 3, how many times does that number show up? And we're going to represent it as a bar. So our largest amount of frequency is 44. That's the largest amount something has shown up. So when we go to our y-axis and we start building it, we need to make sure to get to at least 44. I'm going to go by 2 tick marks again. And I've got 1, 2, 3, 4, 5, 6, 7. Let's go by units of 10 here. 10, 20, 30, 40, and 50. So that one was a little bit less perfect than my x-axis. So then that way we can include all the way up to 44. I was wondering if I could go by units of 5, but then I counted 5, 10, 15, 20, 25, 30, and I couldn't get all the way up to 44. So then I had to scooch down to the next available nice number, which was 10. I'm going to really quickly put bars across. With histograms, we tend to have bars that are just across horizontally, not really vertically, because the vertical bars are represented by your actual bar that is the histogram. And I'll explain or show what I mean once we start drawing. So this tends to be what our blank slate of a histogram looks like. So between 0 and 3, we have a frequency of 9. So I'm going to go here and find about where is 9 on the frequency axis. So I go up here and I say, well, it's just below 10. And I build a bar between 0 and 3 that represents 9. We can even, if you want to, I don't have this on my version of the notes, so this is what it's going to look like. I don't have this, but you could even write in 9 inside of there, so you know exactly what that number is, if you want to. All right, between 3 and 6 is our largest frequency. Remember, going back, it is 44. So I'm going to go all the way up to between 40 and 50. I know about halfway in between is 45. So I'm going to go just slightly below that to be 44. I'm going to use my ruler because I like for it to look nice. And I build in my bar at 44. I can write 44 in it if I want to. And there you go. Go ahead and keep going through. We've got between 6 and 9 is 26. So go ahead and find about where 26 would lie on this side. So halfway is 25, which means 26 is just going to be slightly above that. And go ahead and finish the rest of this histogram. Press pause because the next time you see me, it will be completed. All right, so this is what a histogram looks like. It is just taking exactly what you made in your frequency chart and turning it into a visual representation. So what do histograms tell us? The first thing is it is a visual representation of where the approximate center of the data is. So we can look at this and have a pretty good visual idea of where most of our data lies between. Most of our data lies between 3 and 12. And we could even argue that most of our data lies in between 3 and 9. So that's where it's all heavily weighted, okay? So where the center of the data is a quick thing that histograms can tell us. Another quick thing that histograms can tell us is the degree of the spread. And we call this variation. So you can have a histogram that has data that looks something like this, and it's centered around or clustered around a center. This has small variation. There's not a whole lot of variance outside of this range of data. We tend to stay within that range of data. Versus when we have something that looks like this, where there's not a whole lot of clustering together. It's called, it has more variation. It is spread out or spread out from center. And that means that there is more variation. For better or for worse, depends on the context of the situation. Okay, the last thing that a histogram can show us visually, we can observe the shape of distribution. So we talked about spread and the type of spread that you can have. Well, we can also have the shape of the distribution that we see. We can have a reasonably flat distribution where there's not really anything that's sticking out. They tend to be all the same. A reasonably flat distribution means that there's not something that's happening primarily for a group of people, right? So primarily for a group of people, or primarily for countries, you do not have flat data. Most countries lie between 3 and 6% in terms of their unemployment rate. Whereas if you had information like this, which we're going to see later on in one of our histograms, it's just widely varying. Not a whole lot of patterns to go with. So reasonably flat. Reasonably flat. We can also have something called a skew. Skew is a little bit challenging because it can be very tricky. Because if I have something that looks like this, you can see that it's skewed, right? The majority of your data is off to the left. However, we say that it is skewed to the right. It's skewed to the right because of the tail. So I'll put parentheses tail here. The tail is to the right, and that's why it says it's skewed to the right. Even though it looks like it's moved to the left, that's not what skewed means. So if we were to have most of our data on the right-hand side, we would say that it is skewed to the left. So you can observe shapes of distribution and draw conclusions with that based off of whether there's a certain amount of clustering that's going on. Skewed to the left, skewed to the right, or reasonably flat.